Hi student, and today we will talk about motion in one dimension, and just to try to understand briefly we will start with a few definitions. The first, let us begin. Kinematics. Kinematics is the branch of physics, in which we study about we study about the motion of an object. Motion of an object without considering its cause. Without considering its cause. Okay, so that means what? We'll not talk about what is the reason behind the motion. We are simply studying about the motion, what force is involved. These all things we are not dealing here. Then it's another branch is here dynamics. This is same. This is a branch of physics. We study about the motion, but this time we consider the cause of motion also. What was the factors involved in creating the motion? These all things will be the same definition. The only thing, kinematics, we are studying about motion without its cause. Dynamics, again we study, again it is a branch of physics in which we study the motion, but we considering the cause also. So please you remember the second definition. Third one is point object. Point object. Quickly you recap here. Point object. Okay, so the distance traveled by an object is much larger than its size. Then you can consider that object as a point object. The distance traveled, the distance traveled by an object, by an object is large, much larger, much larger than the size of the object, than the size of the object, size of the object. Then the object is said to be a point object. Then the object is said to be a point object. Okay. So nothing, any big object you can consider a point object. Take an example. Suppose there is a train running from Patna to Delhi. Some 1200 kilometers is there. And this 1200 kilometers is much larger than the size of the train, the length of the train. So in this case, you can consider train as a point object. But same train, if travels 50 meter, then in that particular case, you cannot consider the train as a point object. So everything depends on how much distance is being covered, how much distance is being traveled. Now next is your frame of reference. That is the most important thing. Frame of reference. Frame of reference. Okay. The three mutually perpendicular coordinate axes, the three mutually perpendicular coordinate axis. Coordinate axis. The plural of axis is axis. Along with a time machine. That means along with a stopwatch, a clock, or your wristwatch, along with a time machine. Makes a frame of reference. Makes a frame of reference. Okay. That you know that if you know the coordinates of a particle from a certain frame, then you can locate the position also. Let us take an example here. The example is we are taking. Now let me begin here. Some defining terms is over. There are so many defining terms that are still left. But you go through the book and if you find that important, you note down that one. Now consider this is your x-axis, this is y origin, and this one is your z-axis. Okay. Now you look here carefully. Suppose here is a point object P. Okay. Now what is happening? If your point object P is here, it has certain coordinates to specify its location. Say its coordinate is x, y, and z. And since you have a time machine also, so you can check after passing a certain time whether the position of this object remains same, whether the coordinate is remain same. If the coordinates are remain same, then you can conclude that the object is being raised from the origin of these three mutually perpendicular axes. So from origin, no change of position takes place there. So you can say it is in rest. तो आपको समय देखना है, समय जिस जैसे बीतेगा अगर इसके पोजीशन कोऑर्डिनेट में कोई चेंज नहीं आता है तो आप समझ लेना ये रेस्ट में है with respect to this particular origin. Okay, इसके रेस्पेक्ट में. So you write down if all the three coordinates do not change with the passage of time, with the advancement of time, then the object is said to be in rest from the origin. और कंपैरिजन टू दिस फ्रेम, इस फ्रेम में ये ऑब्जेक्ट रेस्ट में होगा अगर इसके कोई भी कोऑर्डिनेट टाइम के हिसाब से टाइम बढ़ता जाए और इसके कोऑर्डिनेट में कोई चेंज नहीं आए. ठीक है. अब चलो हम बात करें, तीनों डेफिनेशन एक साथ आप कर सकते हो. पहला मोशन इन वन डायमेंशन. तो मोशन इन वन डायमेंशन का मतलब हुआ कि अगर टाइम के साथ साथ इस तीन में से कोई एक कोऑर्डिनेट बदले, सिर्फ एक, कोई जरूरी नहीं कि एक्स ही बदले, वाई भी बदल सकता है, बट बाकी एक्स जेड जो होना चाहिए वो नहीं बदलना चाहिए, या जेड बदले एक्स वाई नहीं बदले. ओके, सो इस केस में इसको हम बोलते हैं मोशन इन वन डायमेंशन. समय चल रहा है, सिर्फ एक ही कोऑर्डिनेट बदल रहा है, कोई एक, एक्स, वाई और जेड। तो मोशन इन वन डायमेंशन को ऐसे ही डिफाइन कर सकते हैं। यू राइट ऑन, इफ one of the coordinate, the position coordinate, one of the position coordinate changes with time, then then the, this motion is said to be motion in one dimension. The motion is one dimensional motion. One dimensional motion. These are some defining terms. Dimensional motion. So anyway, you can make the note here and you can write motion in one dimension. One of the coordinate. Okay. Particular linear motion in a particular direction is said to be motion in one dimension. Suppose the object is falling. The falling. That means what? Your z coordinate is being changed. Remaining x and y does not change. So falling an object is also an example of motion in one dimension. Or a train is going in a particular direction, you can say, till its direction will not change. Same direction. So this is translated of linear motion. Linear motion is an example. In a straight line motion or linear motion is an example of motion in one dimension. Okay. So its direction should not change there. In a straight line motion, it is going straight. The car is running on the road in a particular direction. You can say it is motion in one dimension. Second one, the object is falling. This is also an example of motion in one dimension. Okay. Now, second you can have. If two of the coordinates, if two of the coordinates of position coordinates varies with time, then it is said to be motion in one dimension. Motion in one dimension. So that you have to understand. Okay. So please you check here carefully. अगर आपको motion in one है, sorry, motion in two dimension. दो coordinate बदल रहा है ना, two dimension. One dimension is already being done. The two coordinate changes x z, x y, y z, कोई भी पेयर हो, चेंज हो रहा है टाइम के साथ, तो हम उसको बोलते हैं, इसको हम मोशन इन टू डायमेंशन या मोशन इन प्लेन भी बोलते हैं, और मोशन इन प्लेन. ठीक है. ऑब्जेक्ट इज मूविंग ऑन ए सर्कुलर ट्रैक, दिस इज वन एग्जांपल. या प्रोजेक्टाइल मोशन, दिस इज अनदर एग्जांपल. दिस टू आर नॉर्मली known as motion in plane और motion in two dimension. ओके. 3 में तो आपको पता चल ही जाएगा, तीनों कोऑर्डिनेट बदलेगा. तो जैसे कोई मान लो काइट आप उड़ा रहे हो, पतंग उड़ा रहे हो, तो पतंग का जो लोकेशन है कभी इधर जाता है कभी उधर जाता है, तो वो हो, दैट विल बी एन एग्जांपल ऑफ. या कोई बटरफ्लाई है जो इधर उधर स्पेस में चल रहा है, मोशन इन स्पेस विल बी एन एग्जांपल. तो स्पेस में तो प्रोजेक्टाइल भी घूमता है, लेकिन प्रोजेक्टाइल में सिर्फ दो ही कोऑर्डिनेट बदलता है, ये ध्यान में रखना आपको. तो जब दो कोऑर्डिनेट बदले, टू डायमेंशनल मोशन, थ्री कोऑर्डिनेट्स चेंज, दैट मीन्स थ्री डायमेंशनल मोशन. नाउ यू कम हियर, द फैक्ट आई विल टेल यू. अगर मान लो कि किसी ऑब्जेक्ट का पोजीशन, टेक एन एग्जांपल बिकॉज इन होल चैप्टर वी विल स्टडी अबाउट मोशन इन वन डायमेंशन and we will see some equation of motion also. So many things are being covered here. Now you come here. फटाफट आपको करते जाना है. सबसे पहला ये कि यस, मान लो कि ये एक्स एक्सिस है, ये ओरिजिन है, और यहां पे एक ऑब्जेक्ट का पोजीशन है. दिस इज एक्स जीरो, यानी टाइम जीरो था, यानी स्टार्ट था, तो उस समय ऑब्जेक्ट का पोजीशन एक्स जीरो पे. The object is moving with constant velocity in positive x direction. Constant velocity is v. Now देखो इनिशियल पोजीशन कहाँ है, यहाँ पे है. अब इसकी जो भी वैल्यू हो, वी डोंट नो, तो आप हमको बताएं the object moves with constant velocity v along पॉजिटिव एक्स एक्सिस. मतलब डायरेक्शन हम नहीं बदल रहे. तो आफ्टर टाइम t the position of same object will be what is that? xt is equal to x0 plus v into t. x0. Correct or not? So xt will be the position of object. It is not displacement actually, it is position. अब जो पोजीशन होगा वो इनिशियल पोजीशन प्लस व्हाट वाज द डिस्टेंस कवर्ड. Now you come here. If somebody will ask you what is displacement in this case, so displacement you write down. So displacement is equal to xt minus x0 is equal to v into t. I hope that you can understand. It's a very simple thing, nothing special here. That means xt minus x0 is the displacement actually in x-axis. This one. So this you can write here as s is equal to v into t. तो ये तो आप पहले से पढ़ते आ रहे हो ना कि डिस्टेंस इज इक्वल टू स्पीड इनटू टाइम, या डिस्प्लेसमेंट इज इक्वल टू वेलोसिटी इनटू टाइम. इन दिस वे. नाउ यू कम हियर. अब आपको पिछला हम रिकैप कराते हैं फटाफट. नाउ यू राइट डाउन कुछ डिस्टेंस, फटाफट करते जाते. डिस्टेंस, एक्चुअल पाथ ट्रेवल्ड, okay. Displacement, what is the displacement? Displacement is change of position in a particular direction. ओके. और इसकी मैग्नीट्यूड आप निकाल सकते हो बाय द मैग्नीट्यूड ऑफ डिस्प्लेसमेंट. The magnitude of displacement can be calculated by joining a line from initial position to final position. From initial position to the final position. To the final position. ठीक है. For example, suppose you are given a circular track of radius 7 meter. An object starts from point A and reaches to point B. This point is diametrically opposite. Diametrically opposite point. A to B. The distance traveled. B is diametrically opposite point. So distance traveled is actual path. So actual path is what here? Pretty simple. The actual path is going like this one. Okay. The actual path distance is pi into r, and I hope that is a 22 meters. No, pi is equal to 22 by 7, r is equal to 7 cancels, so 22 meters. But displacement, the magnitude of displacement we are talking, displacement is what? You join the line from initial position to final position. So displacement is, it is equal to diameter d, which is equal to twice of r, and this is 40 meters. This is the magnitude of displacement that you can calculate here. Now, suppose I am taking another example, same figure. If B is here, this is B. Okay. Now, can you calculate what is distance traveled and displacement traveled? So, distance is quarter of this. That means half of the half circle. So, it is 11 meter perhaps. This is 11 meter distance. And what is displacement that you see here? Join the line from initial position to final position. So, I hope that this 7, this will be 7 root 2 meter. So, you have to understand this one, distance and displacement. Okay, distance is a scalar quantity, displacement is a vector. So, you need some direction also for locating the vector. Now, you look here, next part is this. I'll talk about average speed. Average speed is equal to, it's a simple formula that you know, total distance divided by total time taken. Okay, but this is a simple formula to calculate average speed. You see in journey what is total distance traveled and you divide it by total time taken. You will get average speed. There is no problem at all. So next you look here. One example I am giving. Suppose you are given the 2 points here, A to B, and a bus is moving, or man, I am taking a man, with some, like this one. And he is going by a car or by bike or by bus, any means there, any vehicle he has taken and he traveled. While he was going A to B, the speed was 50 kilometers per hour. And while he returns, that time its speed was 60 kilometers per hour. Mind you, it's an imaginary question only, virtual. 50 kilometers per hour is constant speed going. Practically it is not possible, but we can consider here. You were asked, what is V average? The V average, normally what mistake we are committing is, we're simply taking the average of 50 km per hour and 60 km per hour, which is wrong. वो गलत है. You should not take the average of these two speed. You have to take total distance. So consider the distance is x. So A to B x, B to A x. So total distance is here what? Twice of x divided by total time. So while going from A to B, the time taken was x by 50. Okay, and while he returns there, this is x by 60. And you calculate, you will get some 54 point something, 54.54 kilometer per hour. It is never 55 kilometer per hour. So these are the basics that you should keep in mind. That the average speed, whenever you calculate, you take total distance first and total time taken. Don't take the average of two speeds. Okay, it will be every time wrong. Now you come here. Next is what? Average instantaneous speed. So instantaneous speed, normally differentiation we have done. So V instantaneous is equal to dx by dt. Or dx by dt, you are considering that the x coordinate is being changed. Or you can write dy by dt. This the y coordinate is being changed. Or you can write dz by dt if z coordinate is changed. Okay, so this you consider Vx. You're sure that the only x coordinate will change, and you can take this one. This you can take Vy, and this you can take Vz. But in one-dimensional motion, only one can be taken. But in two dimensionals, any two will be there. Okay, so you should understand. और हम लोग डिस्टेंस को s मान के चल रहे थे, तो वो भी आप लिख डालें. दिस इज व्हाट ds by dt. या फिर r मान के चलते हो तो आप लिख दो dr by dt. Depends on what you are considering. Okay, so this is actually instantaneous speed. Now you come to the average velocity. So you try to understand average velocity clearly. The average velocity is what happens